Hello, welcome to another edition of On.net. Today we have Rowan Miller, who's a member of the Entity Framework team, and he's going to talk to us about Entity Framework and Entity Framework Core, and everything to do with ORMs. Maybe you want to introduce yourself, Rowan.
Yeah, good morning, Richard. Pleasure to be here. Like you said, I work on the Entity Framework team. I'm a program manager, which just means I fill in the gaps of whatever needs doing on the team each day. Uh, Pleasure to be here. Look forward to our conversation.
Cool. So, how about you tell us a little bit, kind of give us an intro to the domain, to um, the domain that Entity Framework solves, to kind of give people a grounding who aren't familiar with that topic, and then we'll kind of go into Entity Framework itself.
Sounds great. So, Entity Framework is an object relational mapper, which is often shortened to ORM for .NET developers. So, an object relational mapper just means I'm a developer. I like to write C# code. I like to have classes. But I need to access a relational database which talks about tables and columns, and its query language is usually Transact SQL, and there's a bit of a mismatch there. And so an object relational mapper solves that by allowing you to write code that maps your C# classes and properties to tables and columns. It allows you to write queries in a language specific manner, in our case in C# and VB.NET, that's traditionally LINQ queries. And then I kind of set that stuff up, and then my application can write .NET code, and the object relational mapper takes care of translating those operations into SQL to talk to the database. As I mentioned, Entity Framework in particular is an object relational mapper for .NET developers. So we would use it in C#, VB.NET applications.
And you mentioned SQL. Is that the only database that Entity Framework supports, or are there multiple?
Entity Framework, the current traditional releases that have been out, and we'll talk about the difference between Entity Framework and Entity Framework Core in a minute. Entity Framework 6.1.3 is a current release. That talks to relational databases, but it's not specific to Microsoft SQL Server. So we have providers for all of the big ones: SQLite, MySQL, Oracle, Postgres, obviously SQL Server Compact Edition, and then a whole bunch of other ones too. And those are not all built by Microsoft. In the EF6 days, we build Microsoft SQL Server and SQL Compact providers, and then all the other ones are provided by either the database vendors themselves or by third parties.
Cool. And are any of those providers open source? Given that we kind of have this open source thing going on these days.
Yeah, so all of our providers are open source. The full runtime for Entity Framework's open source. And then it varies based on the providers. So, for example, NPG SQL Project does the PostgreSQL provider, and theirs is completely open source. Other ones, like Oracle, that's a closed source project run by Oracle itself.
Got it. Do you know if people use different providers more for kind of specific use cases and domains, or is it really just all across the board on, why someone would use, say, the Postgres one versus SQL Server versus Oracle?
I would say it comes down to the data access technology you choose shouldn't govern the database provider that you use. It's usually the other way around. So I want to write an application. I'm a .NET developer. My business has a line of business application that's an Oracle database. If I need to access that, I can't just migrate that application to my database provider of choice. I need to find a provider that will work with the databases I have. And then, yeah,
Yeah.
obviously, as we look at different systems, different people, different organizations have a preference for different databases, and then different situations do as well. So if I'm storing a small amount of local data, then SQLite or SQL Compact a better choice than spinning up a full SQL Server or Oracle instance for those.
Makes sense. Can you also talk a little bit about when would be good guidance on when to use an ORM like Entity Framework, and when maybe you should just use kind of the lower level data access layer directly?
Yeah, it's a good question, because I think when we document Entity Framework, we talk about it being the recommended data access technology. It sometimes can be interpreted or as you should use EF for every piece of data access you do, and that's That's definitely not the case. Entity Framework is a tool to have in your belt as a .NET developer, but it's certainly not going to tell somebody to use it if they have something else that works for them. It's also not the right tool for every situation. So an ORM saves you time and development cost because it means you don't need to worry about writing raw SQL queries all the time. Uh, you're free to party away in C# and VB.NET basically. That overhead, that layer of abstraction obviously comes with a bit of an overhead. So if you're trying to insert, 5 million rows quickly, an ORM of any case is not going to be the choice, whether that's Entity Framework or in Hibernate or something else that you've chosen. And so there's a bit of a continuum there. I could drop down to something like Dapper, which is often referred to as a micro ORM. So it has some ORM-like capabilities, but it doesn't have the full capabilities, which also means it's lighter weight and less of an abstraction, less overhead. And then on top of that, particularly if someone came to me and said, I'm building an application, I need to bulk insert millions of rows, I would probably suggest dropping further down than that and going straight down to ADO.NET. Because in that case, you're going to write more code, but for this operation you're trying to do, you want the best performance you can get. And therefore, dropping straight down to the wire using SQL Server specific features through ADO.NET is probably the right way to go.
That makes sense. Um, can you talk? So you mentioned a couple alternatives to Entity Framework that are in the .NET ecosystem.
Yep.
Specifically, I think you mentioned Dapper and Hibernate. Can you talk about why some people use those technologies instead and how that can be a beneficial choice? And you maybe already covered Dapper a little bit, but not in Hibernate.
Yeah, that's fine. So I think in Hibernate and Entity Framework, there's obviously a lot of heated discussion because people generally prefer one over the other. I think if we kind of look past all of that, they're two ORMs that take a fairly similar approach to solving the problem of the disconnect between .NET code and a relational database. And therefore, I think it mostly comes down to taste. You should pick the one that works best for you. Some people connect more with entity frameworks, particularly as we've moved to code first and modeling everything in code and using migrations to maintain the database or using tools to create a model from an existing database. That workflow kind of resonates with them. And Hibernate has a slightly different approach. It really just comes down to taste, I think. If we look at something like Dapper, if you use Dapper for data access, you're going to write a bit more code, and the code that you write is going to be a little bit more relational database specific. But at the same time, it's lighter weight. You're probably going to get better throughput from it. So I think that one is a trade-off between development cost, simplicity of code, and the maintainability and the possibility for bugs and all those things. Trade it off with, if I want better performance, I probably want something lighter weight. And then I guess, we already talked about this, but there is the .NET SQL client and ADO.NET data access APIs too, which, like I said before, they're just kind of another step down that continuum. More code, more database centric, you'll probably get better throughput.
That makes sense. Well, maybe you can tell us a little bit, since we kind of have presented the domain and some of the different alternatives, what it is that you and your team are doing now with both Entity Framework and Entity Framework Core.
Yep, so let's just distinguish between those two things. So Entity Framework is, we also refer to it as Entity Framework 6.x, just meaning 6 point whatever minor and patch release we're up to. At the moment, that would be 6.1.3. Our team is currently planning for the EF 6.2.0 release, which will have some small features, some bug fixes, and some community contributions in it. Entity Framework 6.x runs on the full .NET framework, so we think of that as ASP.NET, not ASP.NET Core. We would think of that as WPF, WinForms, console applications running on a Windows machine. Entity Framework Core is a movement where we're trying to make Entity Framework available regardless of where you're writing your .NET code. And this aligns with ASP.NET Core and .NET Core, where we talk about cross-platform, and then also some more concepts where we talk about more lightweight and extensible, and really building the Entity Framework that we want to run with for the next 10 years or so. When we compare and contrast the two code bases, Entity Framework Core is new. We just shipped 1.0.0 very recently. Entity Framework 6.x is mature. The code base has been around since 2008, was our first RTM. And so obviously A lot of features, a lot of stability, a lot of maturity on that side.
You mentioned that the new entity framework core code base is, uh, you took you probably took some learnings from what you've done before. You said it's lighter weight. Does it have some of the lighter weightness that Dapper has, or those are kind of different concerns?
I, I would say it's still not a micro ORM. Entity Framework Core is still very much a full-blown object relational mapper. So that means it has fundamentally the reason it's called Entity Framework and it's not just called Data Access Stack X from Microsoft. It's not called a new thing. It still takes the same fundamental approach as Entity Framework. Still has the same fundamental APIs. However, under the covers, it has a very different implementation. Entity Framework 6, the code base, it's been around for being worked on for around about 20 years now. Uh, it's very monolithic. Things kind of interact. It's like trying to move a noodle in a bowl of spaghetti. It's really hard to move things without unintentionally moving other things around. So we tried to break things up a lot more in Entity Framework Core. We have a lot of low-level services. We try to take a pay-per-play approach where if you're not targeting a relational database, and we can talk about that more, you don't even have those NuGet packages installed in your project. The parts of Entity Framework that deal with relational databases are tucked away in a separate assembly, a separate NuGet package, and if you use EF to talk to an in-memory database or to some other non-relational store, then you don't pay the cost of those components. So that's what we mean by lighter weight. And then, of course, one of the big bits of feedback we get on Entity Framework 6 is that it's slower than people would like, and we made a lot of progress on that recently, but we feel like we've pushed the code base about as far as we can. Entity Framework Core we're building in with some of those learnings, as you mentioned, from the ground up to try and build a leaner, faster stack.
That makes sense. So you mentioned, non-relational or NoSQL just now. We were talking more about relational at the start. Can you talk to us a little bit about, why people want that and what that model will look like, and if that kind of opens up any more use cases that we didn't have before,
Mm-hmm.
and also if the coding pattern changes, kind of give us some sense of that.
Yeah, absolutely. So when we first started looking at Entity Framework Core, we had the idea of being able to map to non-relational databases. And we weren't sure if it was a good idea, but we thought we'd give it a go and see what it looked like, and we'd get some feedback on it. The providers that we played around with, we implemented an Entity Framework provider to Azure Table Storage as a prototype, and we also implemented one to a Redis cache. And what we found is that obviously not everything from Entity Framework 6 translates directly to those stores, but the general coding pattern from Entity Framework is actually really quite nice dropped on top of those. So we decided to push forwards with it. Now, we don't have any non-relational providers that are in our 1.0 RTM release at the moment. So Redis and Azure Table Storage, there's no provider you can go and download and use in your application at the moment. But we built Entity Framework Core to be used with those providers. We architected it in a way that works. That's why we prototyped them, to make sure that we were doing that. And then over in the near future, we'll be bringing those providers back and shipping providers for Azure Table Storage and Redis Cache. And then obviously our hope there is, as with other database providers, we have third-party vendors and database vendors that will write providers to make their database of choice work with Entity Framework Core.
Got it. Yeah, I mean, I know a lot of people use MongoDB.
Mm-hmm.
I'm pretty sure that fits in this category. I'm assuming that a lot of people would be interested in a provider for that. Is that right?
Yeah, absolutely. That's one of the big ones we hear about. I do also just want to point out what we're not doing is building this magical data access stack where you write some very high level C# code and we just take care of everything and make it work against every database. What we have is some core concepts, like the idea of having a context that can query entity instances using LINQ and can track changes to those. Those are baked into the core, but then there are obviously specific things you're going to want to do with a database that you're targeting. So if I'm targeting a relational database, I'm going to want to map to tables and columns. I'm going to want to configure cascade delete behaviors. I'm going to want to be able to control DB transactions and things like that. So those APIs come in as extensions when you target one of those providers. If I'm targeting Azure Table Storage, then I'm going to want to configure row and partition keys and things like that. So we're not magically abstracting things away. We just have a core set of patterns and APIs that work on most data stores. Some data stores are probably going to throw when you call some of the core APIs. And then providers and classes of providers add extensions to light up the features that are specific to their data stores.
Um, that makes sense. Um, Maybe just one more kind of question, and then maybe we can switch to some of the demos you have prepared.
Mm-hmm.
So you talked about how Entity Framework 6.x is fundamentally a Windows technology.
Mm-hmm.
And then you mentioned how EF Core is going to be a good option for the ASP.NET Core, .NET Core products, independent of which operating system they're running on.
Mm-hmm.
What about the mono Xamarin space? How does EF apply there?
So Entity Framework Core will work on Mono today. There are a few caveats when you do that. For example, when you run against SQL Server, you're using the SQL client implementation that's included in Mono, and there are some issues with that. That's a little bit behind where the .NET Framework itself is up to. So one example you hit, I think it's when you query decimal columns, you can run into some issues there just because the implementation in SQL Client in Mono doesn't handle decimal columns. So those are some examples of running on Mono. In the Xamarin space, we're actually working with the Xamarin team at the moment. They're in the process of implementing net standard support, which is what Entity Framework Core is built on top of. Rather than going back and targeting the portable profiles to make Entity Framework Core work, we decided to stick with .NET Standard because that's where we're headed in the future, and Xamarin is in the process of lighting that up at the moment. So we actually made a big step forward in that yesterday when the Xamarin team released a beta of their product with net standard support. We still have a bit of work to do before Entity Framework Core actually runs there, though.
Okay, yeah, I noticed on Twitter that they support, or yeah, preview support of .NET Standard 1.6,
Yep.
which is the highest version. So that's excellent. Yeah, and it should help libraries like Entity Framework, which will be great.
Yeah, it's actually an interesting space we're in because we're obviously part of ASP.NET and .NET all up as Entity Framework, but we're also very similar to third-party libraries in that we don't really have any special dependencies on things in .NET. We typically just build on top of the latest and greatest APIs, so in that way we're kind of like a third-party library as well, which means we're a good test case for some of these scenarios.
Yeah, definitely. I mean, I think the key thing is we kind of have this in the box, out of the box concept,
Mm-hmm.
and yeah, Entity Framework is more of an out of the box concept. So it's yeah, the same as everyone else, just like you said.
Yep.
Well, maybe it might be a good opportunity to look at a demo before we go into any more conversation.
Yep, that sounds great. I thought for demos we'd probably start with a kind of 101 introduction to Entity Framework Core, but this will more or less be an introduction to Entity Framework itself because exactly what I'm going to show is basically the same in Entity Framework Core and EF6.x, so I thought that would be a good option.
Great.
Cool. Do we need to swap over to my screen, or I guess
Already, it's done now.
very good. We were speculating on how that worked before, so
Yes.
all right. So I have VS open here. I have a whole bunch of different console applications. I like to demo just in console. It takes everything else out of the way so that we can focus on EF code. If I go and look at the NuGet packages I have installed in this project here, see that I have Entity Framework Core. On top of that, I don't just install Entity Framework Core, I have to install the provider that I want to target. So for this first demo, we're going to target SQL Server. So I've got the Entity Framework Core.SQL Server package installed. You'll see here I'm using 100, which is our stable release that went out recently. So I mentioned Object Relational Mapper. One of the concepts there is the idea of entity classes. So these are the classes I'm going to interact with as I write my application code. So here I have a blog class, and it has some properties that represent things that I want to be able to save to the database, query back from the database, and reason about in my app logic. And then where we start to dig into entity framework code, EF has the concept of a context called a DBContext, and this thing represents a session with the database. So I use it to query and save instances. When I interact with those instances, everything's kind of rooted around a DB set, which you can kind of loosely think of as a table. It's kind of something that allows me to query the table and allows me to queue up a bunch of changes to be saved to that table in the database. Now what I need to do is tell this context what to connect to, so I'm actually going to override the onConfiguring method. Now this is new in Entity Framework Core. In EF6 we would do a whole bunch of magic behind the scenes to automatically pick a database for you and create it for you if it didn't exist. And what we found is that was great for demos on stage and great for our 101 tutorials, but it really doesn't scale when you're writing a real application. It gets confusing very quickly. So we're trying to do away with a lot of that magic in EF Core, learn from our past, and be a lot more explicit. So I have options builder. I say use SQL Server because that's the provider I want to target. It's worth noting that use SQL Server is an extension method that's available because I have the SQL Server provider installed. So if I'm targeting Redis or SQLite, that method doesn't exist at all.
Right, so it also means SQL Server is not privileged in any way here.
Yeah, which is actually a break from EF6, where SQL Server was built into the main EF package. Now it's split out. SQL Server is no more special than any other database in terms of Entity Framework code. All right, so everybody knows how to type connection strings quickly, so I'm just going to pull in one that I wrote earlier. So I'm telling it to connect to SQL Server, I'm telling it to use my local DB instance, and I'm having a database called demo.efcore101, and I'm using Windows Integrated Authentication. Use SQL Server has overloads where I could provide an external DB connection if I already had one of those as well. All right, so now that we have a context set up, when it comes runtime, EF is going to scan the DB set properties and work out what entities belong in my model. So in this case, it'll be a blog entity. There are also methods that I can override on the context as well. There's an onModel creating method where if I don't like what EF detects by convention, I can go ahead and either override or supplement the model that's built by convention. But I'm not going to drill into that now for a 101 demo. Now, I don't have a database yet. I could use tools to reverse engineer a model from a database if I wanted to, but that's not what I'm doing for this demo. I actually have the model first, and then I want to create the database from it. And I have two options for that. If I want to create the database and then be able to change my model and then migrate the database without dropping and recreating it and losing all my data, I would use something called Entity Framework Migrations to do that. If I'm just starting out, though, I probably don't really care about saving my test data as I'm working around and everything, and so the easiest way is on database, there's an ensure created API. And this will just go ahead and create the schema for me in the database based on what it detected by convention in my model. All right, so I've created an instance of a blog here, so we could say db.blogs, remember that's our DB set property, and we'll go ahead and we'll add in the instance of the blog we created. Now this doesn't actually send an insert statement to the database. Entity Framework Context is a unit of work, which means it queues up changes ready to go into the database. So I call save changes to go ahead and flush those changes to the database. And then let's just look at a query quickly too. So we go get the DB set. This implements the iQueryable interface, so iQueryable a blog in our case. So I can say .order by blog.name. Then I can say toList to pull the results of that query into a list. And then let's just for each over those. And write the name of each blog out to the console. I'm going to go ahead and run this. Now it's going to take a minute to run the first time because it's going through that process of creating the database for me. I actually don't even have the physical database, so it's going to create the physical database on my local DB instance, populate it with the schema, and then run our data access code that we wrote. And we see there, it inserted the one blog into the database, it then ran a query against the database to retrieve that data back out. If we go swap to SQL Management Studio, I'm going to refresh my local databases. Just going to zoom in for folks here. We'll see there's now the database we told it to create. and it created a table based on some conventions it ran. You'll notice it automatically detected that blog ID was the primary key. We detect things like a property named ID or type name followed by ID. Obviously, you're not always going to follow those conventions, so you have the ability to add attributes or extra code to your context to tell EF more about your model if you need to. So that's kind of an introduction to what EF is and what EF Core looks like. Have you got anything to poke around with on that, Richard? Or
The only question, not on SQL Management Studio, but I was curious in the code view if you could press F12 on blogging context to see where it's defined. I didn't quite pick that up.
oh, so blogging context was the DBContext that we defined
Oh,
in here.
sorry, yes,
Yeah,
okay, great.
cool. And if we go look at what it derives from, DBContext, we'll see that it has a whole bunch of data access-oriented APIs, so the ability to add entities, to get access to database operations, so we use the ensure created. I have access to all the change tracking information that's keeping about the entity instances and things like that.
Got it.
So this is kind of, we talk about EF Core being built of a whole bunch of low-level services. DBContext is kind of the thing that orchestrates all of those. We often talk about it as being a facade that kind of coordinates all the lower-level components under the covers.
Makes sense.
All right, should we keep moving on with some code?
Sure.
All right, let's look at performance, because I talked about EF Core being lightweight. It's really easy to talk about performance. It's a different thing to actually have good performance. So
I actually should just mention that we are watching the chat on the off of YouTube. So if anyone wants to ask a question off the YouTube page while we're live, we'll be happy to answer those. Go ahead.
cool. What I've got in this project, I mentioned in our past demo, we started with the model and we created the database from it. In this project, I actually used the reverse engineer tools for both EF6 and EF Core to reverse engineer a model from the AdventureWorks database, which I happen to have on my local DB instance. I have both of those side by side in this application. So I have an EF6 one here, has all of the EF6 entities in there, and then you basically see I have the same model replicated using EF Core as well. That's an important thing to note. You can use EF6 and EF Core side by side in the same application, which can be useful if you're in the process of migrating or testing out, etc.
Can you open up one of those model files, like one of the simpler ones?
Let's just pick on, well, actually, let's go look at product category because that's what I'm going to use for my demo. So,
oh, okay. So what my question was going to be is, like, how does product category differ between EF Core and Entity Framework, and why can't you just share that product category since it looks like it's very simple?
yeah, actually, so the model definitions themselves are actually pretty much identical between the two. The reason I didn't share them was purely for simplicity. I just ran the reverse engineered tool, which reverse engineers the whole model. So I just let that do its thing and dump them into the same namespace. But yes, I could share the same model classes.
I see.
Yeah. And just to highlight that point, if we go look at the F6 one, product category. We'll say there's a little bit more happening in here. I think we were a little bit more zealous about suppressing code warnings and things like that in the EF6 days with our code generation. But I think the other difference you'll notice here, if we look at the name property here, you'll see we're using attributes to say that it's required and has a maximum length of 50. In the EF Core one, I actually generated this with the RC1 tooling. So we actually didn't use attributes to configure those aspects of the name property. We used the Fluent API in the context. But now in RTM we use, well, I guess the tooling is still technically preview 2, but with the current release we do use attributes for that as well. So that's just a point in time thing, which I guess is probably another reason I didn't share them.
Got it.
Cool. What I have here is a very simple harness. I pass in 2 bits of code, one that's going to run an EF6 test against the context, one that's going to run an EF Core test against the context. Worth noting here, you'll actually notice I hadn't seen this before. I have EF7 here. So EF7 was renamed to become EF Core. So if you've heard us talk about EF7 before, EF Core is the logical continuation of that project.
So you need to update your demo.
I do. I'd updated everywhere else. I must have missed that one. All right, so we're going to run these two pieces of code. We're going to run each piece of code 3 times, and it will print out how many milliseconds it took for the code to execute. We're going to start really simple. So we're going to do db dot, I think I'm going to pick on customers to start with. So we'll just pull all of the customers from the database back into a list. I'm going to run exactly the same code for both of them. Just check I set it as a startup project. I did. Let's run. So what we're seeing here, I guess I should probably bump my font up for folks. Let me just do that. So what we can see here is that even for this very simple query, we're seeing around about a 20 to 30% improvement between EF Core and EF6. One other thing that's worth noting here, it's a little bit hard to see in the numbers, we'll see it exaggerate a little bit more, but for the first query, we're basically executing it cold, and so there's nothing cached at the moment. After that, both EF6 and EF Core do some caching to basically save part of the EF part of the query plan. So in the same way that SQL Server starts caching query plans as you use them, EF actually does the same thing itself. It knows, hey, I see this link query. I've already done the work to translate something like that to SQL before, so let me reuse that plan.
So you're saying that if I'm interpreted what you said correctly, you're saying the second two iterations should have been cached, but they don't seem to be faster.
Yeah, it's going to show up a lot more in a second when I do
Oh,
something a lot
sorry.
more complicated. Yeah,
Got it.
obviously a straight select has basically very little translation to do there, so I'll probably should have saved off mentioning that until I get to this query. So I'm going to pull in a query I wrote earlier, which does something a little bit more complicated. Just going to copy that guy, and we'll run the same thing for EF7. Sorry, EF core, sorry. Down here. All right, so let's run this one.
It's nice to see that the link code is completely compatible between the two, that there's nothing special.
Yeah, it is worth pointing out that the EF core link provider is definitely not as mature as the EF6 one. In fact, if I had to say that any part of the EF core stack still needs a bit of work, it would be our link provider at the moment. So it's robust for simple queries, but as you start to delve into the more complicated things, you are likely going to hit limitations. I think we're going to be in a good spot when we come to the EF 1.1 release later this year. We've done a lot of work to improve the capabilities of our link provider. That said, it is quite a bit faster than EF6, and so we see here, we can start to see caching kick in a little bit here. We're dropping maybe 10% on the following iterations. Yeah, we can see though, writing something more complicated, this is actually significantly faster in EF Core.
Is the explanation that EF Core, just the way it's implemented, is fundamentally doing less work, or how would you characterize it?
I'd say there's two parts here. One, yes, it is fundamentally doing less work. Secondly, EF6 was, I would say, optimized for the complicated edge cases. So in EF6, we wanted to be able to take any link query and translate it into a single SQL query. In EF Core, we've been a little bit more pragmatic about that. We've said, hey, okay, it's okay for parts of the query to be evaluated on the client. It's also okay if we need to send two queries to the database, because that's usually faster than sending one really complicated query is to send two separate simpler queries. So I think we've just kind of taken our learnings from EF6, that the idea of translating everything, every possible thing into a single SQL query is not an efficient way to tackle this problem. We can actually see that I have SQL Profiler running in the background here. So let's look at the two queries. This is the one for EF Core. It's not unlike something I might write by hand. And then if we find the EF, yeah, this is the EF6 query that was generated, which, not surprisingly, is slower to execute in the database, as we can see. I think that kind of drives home the point. We have also made a big effort to be, I guess, generate prettier SQL. So even though it may not necessarily execute quicker, obviously in this case it does, but while it may not execute quicker, it certainly looks a lot nicer and much more like what we'd write by hand.
So this is the entity Framework 6.1, I believe. Can you show the other one? That one went by too quickly for me.
Yeah, this is it here.
Oh, wow. Okay.
Yeah, so one of the things that's worth noting here, I had a group by in my query. And because I'm pulling all of the data back from the database and grouping all of the entities, we're actually doing the group by in memory on the client because I'm pulling back all the data anyway. So there's very little benefit in doing the group by on the database in this case. Yeah, so that's one of the big reasons for it being a lot simpler too. It's also worth noting in that case, it's a lot easier to scale an application server than it is to scale a database server. I was actually just talking about this with one of our developers who works on the link provider, Andrew Peters, yesterday, and we were kind of discussing that, if I'm doing a little bit more of the evaluation on the client, now obviously there's cases where evaluation on the client is highly inefficient. So if I was doing a grouping by a property and then doing an aggregate function like getting the count of entities, then I might get 10 rows back from the database if I do the group by in the database, or I could be returning 2 million rows to the client to do the group by. So that would be highly inefficient. But in some cases, doing the processing on the application tier can be faster, which was the case in this case. It's also much easier to scale the application tier. So I take some load off my database server and do things in the application.
One question about that, which is when we talk about the mobile scenario, then doing computation on device might seem less appealing. There, when you talk about doing the computation on the client, might that be on a middle tier service, or how would you talk about what you just said within the context of a mobile app?
Yeah, so if I'm on a mobile app talking to local data, so that would typically be the SQLite scenario. I have SQLite on my device, I use EF to query some data from it. In that case, the computation's really happening on the client anyway, because I'm either doing it in SQLite APIs or I'm doing it in Entity Framework APIs. So in that case, I think it makes very little difference. It is interesting when we start talking about remote databases, which is actually currently not supported yet. The only provider that works on UWP applications and will first light up on Xamarin is the SQLite provider. So for those scenarios, we're very much talking about local data. Even when we do light up, and we do plan to light up connecting to remote databases, I think in that case for big applications, it still makes sense to run a mobile client through some kind of middle tier service and not talk to the database directly. I think just that layer of abstraction, it makes things like security easier. I still think our guidance is going to be you should really go through middle tier, but if you want to do something quick and simple, or you're writing something that you happen to be implementing in UWP or Xamarin, but you know it's always going to run in the confines of your business network, then maybe it does make sense to connect straight to a database.
Right, makes sense.
Cool. All right, let's just close that guy down. So I've looked at querying. We're going to swap over and look at saving some data. Let's pull in this one. So we're going to loop through, create 1,000 product categories, add them to the context, and then save them to the database. Again, you'll notice that I'm straight up copying and pasting code. The only difference here is I'm going to swap, as you pointed out before, I have two different implementations of my domain entities, so I'm swapping to use the EF core one in this one. But for the most part, I'm writing the same code that I wrote above.
Yeah. I mean, I get that this is more of a demo. Is there really a scenario where you use EF and EF core together in an app? Is that maybe, I guess if you were migrating, if you had a big dependency on Entity Framework and you thought that there were benefits to EF core, you might start using it in one part of the app. If that was the case, it seems like you would really want those types to be the same so that they could interchange in different parts of your app that were kind of higher level and unaware of this Entity Framework difference.
Yeah, absolutely. So I think it depends how you're tackling it. That's absolutely the scenario. So I have an existing application that uses EF6 and I want to start adopting EF core, but I'm not going to cut my whole application over to start with. Many applications, especially big ones, they tend to not just have one context in them, they would have multiple models. both from like a code maintainability point of view. Obviously, having smaller, lighter weight models often gives you better performance too, and it's just easier to reason about as a developer. So in those cases, I could take one of those models and migrate it to EF Core. The other option, as you said, is I use the same domain entities, but I choose in parts of my application to use an EF Core model based on those entities. And so, yes, absolutely, you could share the entity instances in those cases. Like I pointed out, the reason here that they're different is because I generated them with pre-RTM or pre-Preview 2 tooling, but also there are probably still differences in there too. I'm sure if I pointed at AdventureWorks, I'm still not going to get identical entity classes. But obviously, if I'm writing an application, I'm going to start with my existing ones and just model those using EF Core. So I'm not going to be generating from a database. So
Makes sense.
yeah. And yeah, the point to your point too, the point of this demo is not that I'm using the two side by side. I'm just doing that to compare performance as well. Let's just pause there for a second too, actually, before we jump back to the perf one, while we're talking about using the two side by side. When it comes to migrating, because EF Core has a very different implementation under the covers, EF6 to EF Core is not an upgrade, it's a port. So there's some APIs that are different, there's some features that aren't implemented yet, and there's some features that won't ever be implemented in EF Core that were implemented in EF6. And there's also the same APIs that have different behavior in EF Core. And so I have some documentation I can point folks to at the end that kind of summarize those things to be aware of. And that's where we learned that the behavior we had in EF6 was really unintuitive. So we took the opportunity to fix that in EF Core and make it what everybody always wished it did. That, of course, comes with the overhead. If I'm used to it doing something in Entity Framework, then it's complicated and unexpected for it to do something different in EF Core, which is one of the driving factors behind why it's not called EF7 and why it's called EF Core. Anyway.
Makes sense.
Very good. All right, so let's run this code. So we are going to insert 1,000 entities. We'll see quite a big performance boost here. I'm not super much going to drill into why that is at the moment. The biggest difference here is that we're actually batching things up during save changes. So instead of a round trip to the database for everything that I save, we batch everything up into a single, in this case, insert statement that is sent to the database.
Right. So this performance test, I'm guessing, is more on a scale of work issue as opposed to the last one, which was more in terms of complexity. Is that fair?
Yes, absolutely. This is a very simple operation. There's just a lot of them, well, 1,000. So actually not that many. Obviously, this improvement grows exponentially as I have more and more data to insert. So.
Could we try that? We maybe have a little bit of time. Could we, put another 0 on the end of that number and see if you're telling us the truth?
Well, yeah, let's run it and find out.
Okay.
I'm not sure how long this is going to take, so we might be here a while. Another really good way to kind of push those numbers even bigger is to connect to a database that has some latency in it. So I don't have it set up to do now, but in the past, if I've hooked this up to a remote SQL Azure database and run it, and in that case, I actually have to drop the numbers down because the EF6 one takes too long to execute. So
how about we just leave that running for a second? We'll just talk about something else for a moment.
Yeah, well, let's come back to this one. I'll leave it running in the background, and we can.
Yeah. So I actually have a question about SQL Azure.
Mm-hmm.
That's kind of a new. Obviously databases have always been network connected in the sense that they're often not on the same machine as the code that's running, but it's fundamentally in a different data center with SQL Azure. Well, I guess your code could be running in Azure as well, but it's definitely further away in some sense. I guess I have two questions on that. One is, do you have to write your entity framework code as a entity framework user differently when you're using a cloud database like that? And then the other one is, be curious to hear about the way you test as a team. Like I can imagine, you've got a bunch of SQL servers and Oracle servers and those kind of things in your lab. Mm-hmm. I'm assuming you do some kind of testing with SQL Azure, and maybe you could tell us a little bit about that. So those two questions.
Yeah. So in terms of writing code, At the moment, there is one thing you need to be, well, I guess there's two things you need to be aware of. One, Entity Framework abstracts some of the database, but you still need to be aware that you're performing I/O operations to a remote resource. So you you need to be aware that every time you execute a piece of code, especially if it's a highly latent database, that there's going to be a pause there. And in some cases, it makes sense to cache things, and it probably makes sense to cache more things when that latency to the database is greater. The other thing you need to be aware of when we talk to a remote database is that there's a higher probability of getting connection dropouts. And so we need to have retry logic to test those out. In EF Core 1.1, we'll actually have built-in retry logic for Azure. We'll have a kind of generic retry strategy, and then we'll have an implementation of that that's specific to Azure. Azure has some very clear guidance on what kind of exceptions should just be immediately retried, which ones you should wait for a little bit and then retry. And so we have an implementation of that for EF6, which we've had good feedback on. It works really well, so we'll basically port that across to EF Core as well. We don't have that yet, though, so if you're using the 1.0.0 release, then you need to put try catches around I/O operations to retry them if it makes sense.
I see. So yeah, people will probably be wanting that one to come along.
Yeah, absolutely. I would say a production database that has any real significant traffic hitting a SQL Azure database is going to want that retry policy in there, which is obviously why we're prioritizing it and working on it. What was your other question? Sorry.
About testing.
Oh yeah, testing. So we actually have a test suite on our GitHub project that we add to whenever we implement a new link translation to translate to SQL, or we implement any other piece of functionality, or we fix a bug. We add a test suite, as pretty much anyone who writes software does. We've authored that test suite so that it can be used by other providers as well. So our test suite has some kind of shared base class libraries, and then we have the SQL Server and SQLite implementations of that test suite that we run ourselves. And we then have third parties, so PostgreSQL, the NPG SQL provider, they use our shared test suite and run the same tests that we run, obviously with some tweaks by deriving from our shared libraries and doing the Postgres specific parts of it. SQL Compact also takes the same approach. They run our same test suite. We obviously run that test suite on a continuous integration server, and we've also built the test suite so we can control which database it connects to. So we run it, by default, we run it against the latest stable version of SQL Server, but then we also have secondary CI runs where we're continually running our tests against the versions of SQL Server we support. Currently, we say that we support all the way back to 2008. And then we also run against SQL Azure to make sure that our tests pass against SQL Azure as well.
Makes sense. So one, or maybe should we go back to see how that did that complete? And then I have one kind of final question.
Yeah, there we go. So.
Wow.
Yep.
That is a difference.
Yep. Yeah. The difference here being every time I go through, I mean, we're up to 10,000 round trips to the database versus this wouldn't all be going in a single batch. EF is smart enough to understand the limitations of SQL Server. So there's limitations on how many characters you can have in a statement. There's limitations on how many parameters you can pass in. So we'll be breaking that up into separate batches to meet those requirements.
Yeah, that one's a bit crazy.
Yeah, so that's what's at 137 seconds versus 21. So yeah, that's. Yeah.
No, I think.
No, versus 2. Sorry. Yeah.
No.
Yeah.
Yeah.
Quite significant. So,
yes. Yeah. So the EF Core one is almost taking no time at all.
Yeah.
Relatively.
Yeah, and I mean this would be a real blocker. You can imagine if you're trying to upload 10,000 entities using EF6, then having a user wait for 137 seconds. Now, I do want to be fair. There are some things that you can do in EF6.x to speed things up, and I have actually demoed those before. And I did the same demo for build this year, and I went through and I highly optimized the EF6 code to do all the tips and tricks you can do to make things faster, and it's still EF Core blows it away in terms of numbers. I think we get down to more like 60 or 70% improvement, but even with everything you can throw at it to make EF6 optimized, it's still way faster.
And an interesting question then is, obviously what we're seeing right now is EF Core out of the box
Hmm.
with no configuration. Does it present opportunity to be further optimized as well, such that it could actually run faster than what the out of the box behavior is?
There are some minor optimizations you can do. So when I talked about the optimizations for EF6, we actually took those learnings and we architected things fundamentally differently so that we don't have to do all the work that we do in EF6. One of those big ones, every time you add an entity to the context in EF6, we have to scan through all of the entities in the context to see if anything has changed. You can imagine that operation starts to get really big as I'm doing this, especially when I have 10,000 entities to scan through. Now you can switch that off. That's one of the biggest optimizations. And that, like I said, that drops us down closer to the 60% mark once I start doing that. But I need to be very clever or cautious when I'm writing my code to make sure I only switch it off when I can really switch it off. Because you
Got
can
it.
fundamentally break EF and get unexpected side effects. You can get wrong data being saved to the database. You can get exceptions if you don't do things correctly. We architected EF core so that we don't have to do all that work anymore.
Makes sense. Okay, my last question is, you and I both work on open source projects, both open source software product as well as open source documentation.
Mm-hmm.
I think it'd be great for you to tell people both how those projects are going from kind of an open source perspective, and also what the opportunities are for people to contribute and get involved.
Definitely. So EF's been open source for a while now. We've been open source since we started working on EF6. We took everything that had been internal, bits of it had been public before, we made it the whole thing open source and started taking contributions. And I'd say it's been a steady uptake since then. We weren't flooded with pull requests as soon as we did it, but over the time we've built, I think, a community where people are very willing to contribute small fixes when they hit them. And then we also have a smaller group of contributors that contribute quite a bit of code to our code base. So at the moment, I think of like Shay, who works on the NPG PostgreSQL provider. We've had a lot of pull requests from him that add features to the stack. And then we have Eric Jensen, who's an MVP. He has also contributed a lot of stuff over the years to Entity Framework too. So we see everything from people fixing typos in documentation, which is great because in the past you would find a typo in a document, you would submit an issue, it would sit on my desk until I had a minute to go fix it, and then a couple of months later the fix finally shows up. Now a pull request comes in on GitHub and I look at it and it looks good, I just hit the merge pull request button and it's done. It takes me 10 seconds to process this because someone's already fixed it.
And it goes live much quicker.
Yeah, and our docs at the moment, I think they take about 30 seconds to build, so it's live on the site within about 30 seconds too, which is different than it having to replicate in a whole bunch of different places through some complicated internal infrastructure. So, yeah. So I think all that to say we're seeing a wide range of contributions, and it doesn't stop at code contributions. We get a lot of bug reports. The thing I actually love these days, some of our core contributors have started responding to people filing issues. So if someone files an issue where they're just doing something wrong, it doesn't even have to wait for someone from the EF team to go and tell them, hey, you probably want this API instead. We have people out in the community who will actually follow up and answer questions for people, which is great. I even love it. Someone will post an issue that's missing a repro, some code for us to be able to reproduce it, and we'll have community members go and be like, hey, if you want the EF team to look at this quicker, you should probably just share a console app that shows why it's broken, which makes our job a lot easier, which doesn't just mean we get to sit back and drink more coffee. It means we actually get to spend more time implementing features and writing documentation and things like that.
Makes sense. Okay, I think we're getting pretty close. Do you have any closing words or or any more statements about the 1.1 release that you'd like to share before we close?
So I think there's two things I'd share. One is if you want to get started with Entity Framework Core, then docs.efproject.net is the place to go to. That will give you everything you need, getting started 101 content through to more advanced topics like working with transactions or things like that. So that's a good place to head. Similarly, I wouldn't just say because EF Core is RTM, keep in mind that it's a V1 product, which means it's new and it doesn't have everything implemented, and it's not as stable as it will be when it's a V2 product. And so I wouldn't just automatically assume that this new thing has been released and therefore I should be using it. We're still saying to folks like EF Core is there and we're supporting it, and we obviously didn't just ship something that is completely useless. Uh, so it's definitely an option for you, but don't just assume that it's the only option. So EF6 is still a good, valid, solid, mature option for a lot of applications. EF Core has a lot of benefits over EF6, but you should just be aware of its limitations at the same time. And that website that I mentioned, docs.efproject.net, has a whole section dedicated to comparing and contrasting EF6 and EF Core and helping you decide which one is the right one to use.
Makes sense. It's not unlike how we talk about .NET Framework versus .NET Core. One of the ways I talk about it is if you have a particular need for a cross-platform solution, then that would push you further down the path of adopting these core options. If you're perfectly happy with the setup that you have today on Windows, then the wait and see approach might be a little bit better.
Yeah, absolutely. I mean, there's always that trade-off, right? We want to polish our software for longer and longer, so it's better than when we release it. We also want people to be able to use it if they're okay with the limitations. And so as you know, you have to draw a line in the sand somewhere. We chose to draw it where our code base was at now, and so we have 1.0 available. If it doesn't have what you need, then just be aware of it and ignore it for the moment. Keep using EF6 and use it when it's at a state where it meets your needs. On that, would I use it, would I not use it? I would say that probably one of the biggest reasons you would look at using it is performance. And one of the reasons you would be cautious of using it is the either missing features, which are listed in those docs that I talked about, and the maturity of the link provider. Is it going to be able to translate all my link queries, or am I going to hit issues?
Right, and fortunately that's all point in time.
Exactly, yeah.
Okay, well this has been a great conversation. We should probably have you on the show again in like 6 months or something like that to talk about the progress, particularly after we ship 1.1 and kind of give an update of where we've landed there. Yeah, I really appreciate having you on the show today.
All right, thank you very much, Richard.
Okay, folks, thanks for watching, and we'll update you with the next guest on the show. And again, thanks for watching.